So now I've got 4 more examples. This time we have radicals and we have fractions, and we have both, and then we have neither. And so if we look at the radical, we're supposed to take the radical and set it greater than or equal to 0. And so I'm going to have x plus 9 is greater than or equal to 0. And I solve that, and I have subtract 9 on both sides. And I have x is greater than or equal to negative 9. Okay, now I didn't do the number line on the previous ones, but just to refresh your memory, if x is greater than or equal to negative 9, I would have this. And that would be a hole where the 9 is. Not a hole, a closed circle where the 9 is. And so in interval notation, this is going to be negative 9 to positive infinity. That's what that would be. Interval notation is left to right, so that's my domain for this one. And it's got the bracket on the negative 9, because this is a solid and then going greater. Okay, number 4 has a fraction as well, but it and a radical. So this is what we're going to do. We're going to take what's in the denominator and set it just greater than 0, because it can't equal 0 because it's in the denominator. This is a both situation. And so I'm going to solve this, and I get 2x is greater than negative 5. Divide by 2, x is greater than negative 5 over 2. Okay, so again, we're at a x is greater than negative 5 over 2. And so again, if you were to do a number line, negative 5 over 2, there she is. And then greater than that, this one would be an open circle. And then go that way. And that would be my domain. And so in interval notation, the domain is going to be open parentheses, negative 5 over 2 to infinity. Okay, now number 5 has both as well, but we've got the radical that we'll do, so we'll do x plus 2 has to be positive, greater than or equal to 0. And then the denominator, we have to do it separately because they're separated, equal to 0. So we will do both of these. Okay, so the inequality, we'll subtract 2 on both sides, and x has to be greater than or equal to negative 2. And then for this one, we have factor it into, let's see how this factors, 5 and 2, a plus 5 and a minus 2. Set each factor equal to 0. And I get x cannot be negative 5. And I get x cannot be equal to 2. Okay, so now again, I'm going to do my number line so we can see how this is going to work when we do the interval notation. Okay, so on my number line I have negative 2. And here's negative 5. And here's positive 2. Okay, so x can equal, x has to be greater than or equal to negative 2. Okay, and so what that does is it basically gets rid of this negative 5. I don't have to worry about that because x has to be greater than or equal to negative 2. So we're looking at negative 2 and greater. But it says x can't equal 2, so then I have a hole right here. Oh, didn't mean to do that. Let's try again. I have a hole here. And so that would be what my number line would look like for my domain. X can't equal -5, but it can't equal -5 for the numerator either. So this is what my domain is going to look like. And in interval notation, it's going to be a bracket for the -2, and then a parentheses for the 2, and then we're going to skip it to positive infinity. That is going to be my domain for this one. Very complicated. Okay, last one, we have a quadratic. It doesn't have anything on it. This is a neither case, and so the domain is all real numbers, which is denoted by -infinity to positive infinity.